Hi students, this is Mr. Yao. Today we're going to talk about 2.4 where we will learn how to simplify radicals and add and subtract radicals. First, let's learn how to simplify radicals. We're going to access some prior knowledge we have learned, which is factor tree. So in order to make a factor tree, we're trying to find what are some small numbers that can go into a certain number. So for example, 72. We're going to try to take it apart. We know 72 can be taken apart as 2 and 36. I normally just start with a very small number and leave it on the left side. So I try to take apart more numbers on the right side. So now 36 is still even. So I can take out a 2 again, then I'm left with 18. Still even, take out a 2, I'm left with 9. And then for 9, I can take it apart as 3 and 3. So now I can actually just take a look at everything that's kind of not branching out anymore. That means 72 can be rewritten as 2 times 2 times 2 times 3 times 3. And since we have learned exponent already, there's 3 2's, so that is 2 cubed, and there are 2 3's, so 3 squared. Now let's work on 216. Same thing, it's even, we're going to take out a 2, we are left with 108. Take out a 2, left with 54. Take out another 2, left with 27. Take out a 3, left with 9. Now that's 3 and 3. I'm going to take all the numbers that is not branching out anymore. So 216 can be written as 2 times 2 times 2 times 3 times 3 times 3. And the exponential form is 2 cubed, then times 3 cubed. Now that we know that, let's have a look at some radicals. When we actually try to take apart our radicals, here are the steps. We find the factorization of the number inside the radicals. That means we're trying to take apart 252. So start with 2, left with 126. Then take out another 2, I'm left with 63. This time it's not even anymore, but I know it's 7 times 9, so I'm going to take out a 7. I have a 9. I can take apart a 9 as 3 and 3. So again, I'm just looking at the numbers that is not branching out anymore. So I can rewrite my 252 as 2 times 2 times 3 times 3 times 7. So that is the first step. Step 2, we're going to determine the index of the radical. So in this case, we see there's actually no number there, which means it's going to be a 2. Okay, and so I'm looking for pairs. Now step 3, whatever pair I see, so first I see a pair of 2's. So I'm going to take out that 2. And then I see a pair of 3's. So now I'm going to take out that 3. But I don't have any 7 pairs, so I'm going to leave that 7 inside the square root. So 7 stays inside. Step 3 is move each group of numbers or variables out of the radical and keep one of them for each group. So I did move the 2 out, and I leave the 2. I move the 3 out, I keep a 3. So last step, I'm going to simplify both inside and outside by multiplying. So I have this 2 times 3, that gives me 6. The inside, I only have 7 left, so it's 6 square root of 7. That is how we take apart 252. Now let's look at more examples. Example 1, 40. I'm going to do the factoring, so it's an even number, 2 and 20, even again, 2 and 10, even again, 2 and 5. So now look at all these numbers that's not branching out. So it's 2 times 2 times 2 times 5. So I'm looking for, because this number right here is 3, so I'm looking for triples. I see I have a triple of 2, take it out, but I still have this 5 left inside, so cube root of 5. There's nothing to be simplified outside or inside, so that is my final answer. Next, I'm going to take apart 81. It's not even, but I can see it's 3 times 27. And I'm going to take apart the 27, 3 times 9, and then it's 3 times 3. The numbers that are not branching out, so it's 3 times 3 times 3 times 3. Again, I'm looking for, since the index is 3, I'm looking for triples. So I have a triple of 3 right there. So I'm going to take it out, but don't forget I still have this number in the front. This is negative 2 times the 3 I took out, and I still left with a 3 inside. The negative 2 times the 3 is negative 6 cube root of 3. Now next, things are going to get a little bit more complicated. First, I'm just going to deal with a number. So 125 is ending with a 5, so I can take out a 5, left with 25. Then it can be written as 5 times 5. So I'm looking at these numbers. I have 5 times 5 times 5. The corner number, the index is 2, so I'm looking for pairs. So I have negative 2 times 5, and I'm going to keep writing to see what is left inside. So this 5 is for sure going to stay inside. But then I see, oh, I actually have this x squared. And since I'm looking for pairs, that is a pair of x. That means it comes out to be just an x. And then I see, oh, I have this y cubed. But y cubed, when I actually take out a pair, I still have a y left. And a pair becomes just one y. So that is what I end up with. Now I just need to simplify everything. It's negative 10xy square root of 5y. So I'm going to talk about that y cubed again. So basically, you're just using the exponent 3 and then divided by the index 2, which gives you 1, but with remainder 1. So that's why I have 1y on the outside and have 1y remained inside. You can also think about it that way. Now let's look at the next example. First, I'm going to take apart negative 108. So it's 2 and 54, and 2, 27, and I have 3, 9, and then 3 and 3. Okay, just look at the number that is not branching out. So I have 2 times 2 times 3 times 3 times 3. And the index is 3. So I'm actually looking for triples. And I do see I have a triple right there. So it's negative sign outside, then I have the 3. But one thing to be careful with, I also have this negative sign inside the root, inside the radical. So if you think about it, that negative sign is just negative 1. And if we actually cube root of negative 1, that does give us a negative 1. That means I need another negative sign outside. Okay, now I'm going to be dealing with all the x. So x squared, but I need triples. So that is not a triple, that is just going to stay inside. So x squared still stays in. And then next, I have this y to the 5th power. So y to the 5th power, if I'm counting triples, I do have one y that I can take out, but I still have this y squared left inside. So if you think about it, 5 divided by the 3, that gives us 1y with remainder 2. That's why I have this 1y out here and the remainder 2y inside. Lastly, I just need to simplify it. These two negative sign becomes a positive, so my answer is 3y cubed root of x squared y squared. Okay, now let's learn how to actually add and subtract radicals. We add and subtract radicals by simplifying first, then combine like terms. So we're going to see combining like terms again, but we're talking about radical like terms. That means the radicals that have the same radicand, which is the number inside, and the index, which is the number on top of the root. So example 1. Let's see how we can add them. So I have negative 2 square root of 8 minus 2 square root of 18. First, for sure, I need to simplify them. So I see I have this 8, that can be 2, 4, and then 2, 2. If I simplify that, that is going to be, I'm counting pairs. Since the corner number, the index is a 2, so I'm counting pairs. That means I'm going to have negative 2 times this extra 2, but I still have this 2 left inside. Okay, now I'm going to be dealing with the 18. I have 2, 9, then 3, and 3. So I'm counting pairs. I have the pair of 3. So minus 2 times 3, but I still have this 2 left inside, so 2. Okay, now I'm going to simplify them. That's going to give me negative 4 square root of 2 minus 6 square root of 2. Now I see I do have this square root of 2 right there, square root of 2 right there. So they have the same radicand and the same index, that means they're like terms. Basically, that's our kind of x. Now I can actually put them together. I have this -4 minus the 6, so -10 square root of 2. Next, I'm going to work on number 2. So first, 2, I cannot simplify it, but 45 I can. So with 5, I'm left with a 9, and I have 3 and 3. So I'm counting pairs. So that first term stays there, square root of 3 square root of 2, plus 3 times 3, then I have square root of 5 left inside, and minus square root of 2. Now if I look at them, I have the square root of 2, and I have another square root of 2, but this middle one, I actually have square root of 5. So that is not a like term. That means I can only combine the first and the third one. So it's 3 square root of 2 minus the square root of 2. That gives me 2 square root of 2, and plus, don't forget to simplify that, 9 square root of 5. Now let's look at a more complicated example. I have 4 different terms. I'm going to simplify each one of them. First, start with a 24. So 2, then I have 12, 2, I have 6, 2, I have 3. The last 24, same thing. It's going to be 2, 12, 2, 6, 2, and 3. The only thing to be careful with is that negative sign. Don't forget, when we actually do cube root of -1, that does give us just a -1. Okay, now I can actually start simplifying everything. Since it's a cube root, that means I'm looking for triples. So it's -2, but cube root of this 3 is going to be left inside. Then I'm going to add 3 cube root of 6 plus 2 cube root of 6. And then it's going to be minus. Don't forget I have this negative sign. So it's going to be a -2. And then I have triples again. Count by triples since it's the index 3 times the 2. And I'm left with cube root of 3 inside. So now I'm going to look for like terms. I see I have this cube root of 6 right there. That's going to give me 5 cube root of 6. And then I'm going to look for the next thing. I have this cube root of 3 right there, another cube root of 3 right there. But be careful because the front number I have, this is a -2, but this whole thing is actually a +4. So basically it's -2 at 4, that is going to be plus 2 cube root of 3. Now, even though they're both cube root, the first number is 6 inside, the second number is 3 inside, so they're not like terms, we cannot combine like. Now last example, we're dealing with 4th root. The 5 inside, we cannot do anything to it, but we have 405, that one for sure can be taken apart. 5, then I'm left with 81, and then I have 3, 27, 3, 9, 3, and 3 again. I'm going to actually start simplifying everything. So I have -3 4th root of 5. I'm going to deal with this one in the middle. Since it's a 4th root, I'm looking for 4 of them. So I have 3, but I still have a 5 left inside. Then I have this last one, 2 times 5th root of 5. Next, I'm going to be looking for like terms. I see I have this 4th root of 5 there. I have another 4th root of 5 there. But this last one, I cannot combine it because this actually is a 5th root, which is not the same. So I'm going to combine the first two. That's a -3. That is going to be a -9 since it's -3 times 3. So it's -3 minus 9. I have -12 4th root of 5 and minus 2 5th root of 5. Again, even though they are the same number, same radicand, number 5, but the first index is 4, the second index is 5, so they cannot be combined together. You will not get -14 4th root of 5, and you will not get -14 9th root of 5. You cannot combine the index. These are both wrong. That is everything for 2.4. Thank you.